Hi everyone, I'm Won Lee. We just come to the chapter 6, Categorical Data Analysis. Okay, from chapter 1 to chapter 5 are the basis of statistics. If you teach or study statistics for 2 semesters, then chapter 1 to chapter 5 will be the first semester syllabus. And second semester, you teach or study statistical analysis method, chapter 6, 7, ANOVA, chapter 8, and some extra material, I think. All right, let's see. What is categorical data analysis? All right, here, categorical data is follows multinomial distribution. Multinomial distribution is extension of binomial distribution. Let's see. Categorized data refers to data that is classified into various categories. Specifically, it is data that belongs to one of k classified categories. Categorized data is also called as categorical data, the same terminology. For example, the outcomes of die, die, are classified from 1 to 6. If the die is rolled 100 times, the number of times 1 appears would be x1. Number of times 2 appears would be x2, and so on, up to 6. Okay? Number of times 6 appears would be x6. So naturally, x1 plus x2 plus up to x6 equal to 100, right? The probability of each phase appearing is 1 over 6. Everybody knows this kind of example. We took as a sample coin, okay, for simple probability or random variable, that kind of things. We just took coin and also die. But here, multinomial distribution, categorized data, we took example, a die as example. In data analysis, the ability to convert continuous data into categorized data makes the analysis techniques for categorized data very useful. Okay, so that's why we emphasize this kind of categorized data analysis. For example, age or income data is continuous. Age is continuous. Income data is continuous variable. If age is classified into 6 categories, for example, 20s, 30s, 40s, 50s, 60s, and over 70s, then the age data, continuous data, becomes categorized data. Similarly, income data can be also classified into 5 categories: under $25,000, between $25,000 to under $40,000, and so on, and over $90,000. For such categorized data, the following tests can be possible, can be conducted. First, goodness of fit test, test of independence, and test of homogeneity. Okay, so age or income data is pretty private data, so it is a little hard to get age or income data as continuous because they do not want to answer my income to somebody else, right? So categorize data this way, 25, 40,000, under 25,000, that kind of a categorized data is better or easy to gather your income data. Okay, let the number of categorized items, number of categories be k in general, and let the number of samples that belongs to each category be x1, x2, xk. Then the sum of x's equal to n, right? Yeah. And if the probabilities of each category appearing P1, P2, Pk, P1, P2, Pk, they are k categories. So number of appearance 1 is x1, 2 category 2 x2, and for k xk, some of them equal to n. And the probability of category 1 is P1, category 2 is P2, category K, Pk. Then sum of these probabilities should be 1, right? This is categorized data. The probability distribution function is x1, x2, xk, f over this is n factorial over x1 factorial, x2 factorial, dot, 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 xk factorial. Factorial means 5 factorial is 5 times 4 times 3 times 2 times 1, something like that. You don't have to know that, actually. If you know that, that's good, but otherwise, that's okay. Times P1 x1 power, P2 x2 power, Pk xk power. Okay, this is multinomial distribution function. Let's see. Expectation of xi will be n times pi for die 1 to 6 up to 6. What is expectation of x2? That is 100 times. Okay, n is 100 times. 100 times its probability 1 over 6. Actually, x1, x2, x6, the expectations are same value, this value, n times pi, I from 1 to k. Binomial distribution is a special case where they are only two categorized items, right? Fail, success, or fail, success, and fail. Success number x, then fail number of failure will be n minus x, right? So n factorial divided by x factorial, n minus x factorial, p power x, 1 minus p power n minus x. This is the binomial probability distribution function we already studied. So it is just extension of binomial. In general, they are k categories. Okay, this kind of data can be tested for goodness of fit, independence, and homogeneity. Okay, this is it today. Thank you. Bye.